So, my name is Sindre Osnes. I work as an architect in Capgemini, and I'm going to be talking a little bit about the psychology of development. Now, the first concept I want to go into a little bit is one that is closely tied with business. It's called the sunk cost fallacy. Just to illustrate it a little bit, I have an example. You have a project that is estimated to cost 150 million. Now, the expected return on that investment is 200 million. So, in general, you'd think that's a good idea. Now, all of a sudden, your expected return has been reduced to 120 million. Not such a good idea anymore, is it? But let's say that happens when you're 30 million into the spend. But 30 million has already been spent, so the remaining portion that is going to be consumed in the budget or in that project is 120 million. Now, the rational basis is then that you have to spend 120 million to get 120 million back. So you're at break even. Still not a really good idea, but it doesn't break you. Now, let's say your spent budget is 100 million. Now, all of a sudden, that 120 million return is a good idea because you only have to spend 50 million from that point in time to get that return. If, on the other hand, the expected return is down to 40 million, you're back to, I'm getting less back than what I still have to put in. Where the fallacy comes in here is that we as humans tend to ascribe a lot more value to what has already been spent. That 100 million means a lot more to us, potentially, than the remaining 50. And that tends to affect how we make decisions. It means that we stick with things a lot longer than we should. It means that decisions that should have been made are not made. Now, this becomes quite important after I go through the next concept, which is known as Maslow's hammer. This concept is also known as the law of the instrument. Now, most of you probably don't recognize that title, but you might recognize what it says. If all you have is a hammer, everything starts to look like a nail. Now, if you put these two together, you get more that if you have a very important hammer, you start looking for nails. We see that with large procurements where you all of a sudden have a large amount of money invested and you start to want to look for a way to recoup that investment. You start pushing things into where they don't necessarily belong. So, say you have a large data center contract. You start to want to put things into the cloud because, or into that data center because you've invested that money, so you want to recoup it, even if that might break a lot of the things you have, which, and the guy that built it probably retired 20 years ago, so nobody knows it. Every little protrusion you find on any little thing, you start to want to use that hammer to whack it down, not necessarily understanding the consequences. But this is not just an organizational issue, this is also an issue we have with us as people. So I want you to think about it a little bit. What is your hammer? What's a tool that you tend to use more than any others? Could I have some input from the audience? Do you have any suggestions?
React.
That's a good one. Any more? Okay, then. Yeah. So the first one I tend to go to in this sense is the programming languages. We tend to have preferences in which ones we work with. It's usually based on what we work with the most or what we find interesting at that point in time. But it still becomes a bit of a problem where we start looking for where can we use this skill set, not necessarily what skill set does the problem space require. Now, this can also be extended to your cloud providers. They have different tooling. They have a lot of different different services that they use. It can be your DevOps stack, so where your Kubernetes, your Docker, your Git, your GitHub, you name it. And then it's your storage. It's your database, Redis, Postgres, MySQL, MongoDB. Just pick your poison. And then the one hammer that seems to be everywhere nowadays, AI. Now, this is an interesting one in that we don't necessarily have as much control over it. It is non-deterministic, so even if you feed it the same problem twice, it doesn't necessarily say the same thing. The other thing is that how to use it isn't necessarily well defined. There's a lot of things coming out of the people that are making these systems that is not necessarily true to form in terms of how we actually perceive the value once we start getting hands-on with it. Because most of our solution spaces are maybe not entirely unique, but bespoke. So not everybody is deploying a to-do list app 50,000 times. Some might, I won't. So in most cases, you have a problem that is specific to your space, and it might get you started, but you might also end up with a solution that is 10 times longer in terms of number of lines of code than it needs to be. And it can very quickly lead into the final layer, which is you. You become the last tool in the chain. So if you've ever been on a project where a lot of people have potentially retired or moved on, and there's one person left that seems to be the one thing that holds everything together. That person is not a solution to the problems anymore. They're a tool in the chain to get this thing working. At that point, you're not solving problems, you've just become the hammer. And it's one that's even bigger than AI. And it's also one that doesn't scale. Speaking from personal experience, if you end up in that situation, you do not have any autonomy left. You end up being at the mercy of when everybody else has an issue that they need solved. So, how can we fix it? So, the first thing is to keep learning. The more you learn, the more you know where things tend to break, and also learning the signs of when you start to be put into the position where you become part of the toolchain. Learn the warning signs, like is the size of the team you're in that are responsible for the solution, are they dramatically reducing without any backfill? Is the development cycle slowing down because everything is depending on you? Are you being pulled into like 80% of the pull requests? Like, you see warning signs like that, and you need to act. But also learning different tools in terms of like learning a new programming language and so on, so that you actually understand what the negatives of your solution is, so that you can actually deal with those problems on a more long-term basis, rather than everything's on fire, I need to fix it now, and then the next fire starts, because then you have no way out. And then it is to refine what you know, because the better you are at what you know, the easier it is to do it. So, and it also means to disseminate the knowledge that you have so that you are no longer the single point of failure. So extricate yourself from the situation where you are the single point of failure. Now, this is not always easy. It is quite simple to be in that situation where you learn, but it's not necessarily easy to put it down on paper in the documentation, and then who reads the documentation, right? And then getting a developer to write a documentation in the first place. So it's not always fun, but it needs to be done because, as I said, you very quickly get absorbed into the solution itself. David Whitney spoke about accidental design, and this is kind of a part of it. you're not designed to be a part of the system, but you are. And it's just trying to minimize how big a part of the system you are, and more how much can I contribute to this thing working properly even after I'm gone. And also trying to avoid the slash and burn loop of some person contributing, and then he's gone and somebody else tried to fix it their own way every single time. Each person brings their own hammer. Now, the final step here that I want to mention is start asking why. If you're uninformed of why something is happening, you're not in a position to push back on the decisions that are being made. Now, it might come from corporate that they want to push AI into everything, because that seems to be what's happening everywhere. But if you don't really understand why that's happening, it's kind of hard to argue that it shouldn't be happening. You can say that, in theory, this doesn't add value to us. But then they cite a study that it makes developers 20% more productive. If you understand that that's where they're coming from, you might find the study that shows that developers think they are 20% more productive, but they tend to be 5% less productive. There are studies like that as well. Or the studies that show that how easy it is to poison an LLM by just exploiting a less established solution space. So if you just point a lot of information into a space that is not really widely disseminated, the next time somebody asks a newly trained LLM about something that corresponds to your solution space, whatever you put in there tends to show up. And that has been the source of a couple of attack vectors. And then it might be that, okay, we've invested so much into this. Okay, but then you start looking for the numbers. Okay, what are we going to get back if we put this into our solution? Like, what's the cost benefit? Because even if you, as a developer that is nominally an individual contributor, if you don't really understand why it's happening, you just go along and, again, you lose your autonomy. Now, the one that's probably closest to most of us is, why is a particular technology chosen? Like, why that programming language? Is it because that's where most of our skill set is, and the cost of training another skill set is prohibitively expensive? Okay, then you have your rationale. But if it's just because it is new and shiny, then what's the rationale behind it? Yeah, it might look good on your resume, but it's not going to make the solution run any faster. It's probably going to slow you down in getting it to production in the first place. So just asking why continuously makes it so that you are better positioned to actually provide solutions rather than just being a cog in the wheel. And that's it.